Okay, so relative motion. Relative motion. So the most important thing to know, the most important, and by the way, to anyone in calculus and vectors, this will be a big part. This will be a big part of the upcoming vectors unit. And in almost an entire chapter is going to be, or entire, a couple of sections in the vectors chapters is going to be what is going to be dedicated to relative motion. Okay, so you'll get to see it in a physics class and also with Shivers in a math setting. Okay, so the most important thing to realize, so go ahead, copy that, the little part, the blank one. So the most important thing to realize about relative motion is that it only happens if you have more than two, and get used to this word in any physics course, observers. Okay, observers. Okay, by the way, observers is just a fancy word for, in physics, in a physics setting, for any object in the system. Okay, an observer does not actually have to be a person, like an actual living person, observing the situation. As long as there's an object that we assume there could be an observer inside of it reporting to us, that's called an observer. Okay. So you need at least what? You need at least how many observers for a relative motion problem? At least how many? Three. You have to have more than two. You have to have more than two, which means three or more. Could I give you a relative motion problem with 10 observers? Of course I can. I will never do that. I'm always going to give it to you in what? In what? The minimum number, which is three. There was absolutely no more physics to be taught if you have 4 or 5 or 10 observers. Three does the trick, so we're always got to keep it to three. Okay? So more than two observers, three or more, are involved in reporting the motion of a specific single object. There's the issue of perspective. Can someone tell me another word that could also stand in for perspective? Also starts with a P, Jeanette. Point of view, exactly. Was that the same one as well? Yes, point of view. Okay. Everyone, every observer potentially could have what? A different point of view. Okay. However, so this simply means that two different observers can see. I gave you three words for see. I can use the word see or what? It's in your notes. See or perceive, perception, or report. Okay. So sorry, record, yes. Different ways in which an object behaves. But here's the thing. Since everyone is reporting from their own perspective or their own point of view, technically everyone is still correct, even though the reported numbers could be what? Could be different. Exactly. That's the whole idea. I'll give you an example. Okay, everyone, pencils down. Just look at me. Okay. So Josh, just okay, face me. Just look at me here. All right. So okay, am I moving right now? Is any one of you moving? All right. So I'll move, and just tell me how fast and which direction. So basically, what my velocity is. What's my okay in paces per minute? Sorry, in paces per second. How many steps do you think I was taking per second? One. So what was my velocity? 1 step per second. In which direction to you? This is all what? East. Okay, that makes sense, right? Okay. So did all of you see me the same way? No, no. Forget the 3D idea. Did you all see me move the exact same way at the exact same pace? Yep. Okay, Josh, get up. Stand by the recycle bin right there. And now I want you, both of us, to walk towards each other at also what? 1 step per second. Three, two, one, go. Okay, so we met. Did you still see me move the same way as before? Did you see me move the same way as before or slightly faster? Slightly. Why? Because you yourself were what? Yet, am I still the same object from before? So you report 1 pace per second, sorry, 1 step per second, yet you report what? Twice. Why? Because every step I take, you also what? Take another. So it took me what now? It took me less time to reach you than what? Than before. Is it making sense? So the perspective stayed the same or changed? Changed. But did I change? Thank you. Awesome. So whether we go with Josh's report of Mr. Ramadan's speed, or sorry, speed, let's say, was 2 steps per second, or anyone else's, which would be what? You're correct. He's correct because they have to do with different what? Perspective. Our whole idea today is to relate those what? Is to what? Relate those to perspective, or three or four, depending on how many observers are reporting. Okay? Awesome. All right. It's obviously much easier as a concept, but we will see how to do it actually in a math setting. All right? So after all, the object, me, is the same with the motion, with one motion that is taking place the whole time. Okay, so everyone, pencils down. Let's do the same animation that we did in grade 11. Okay, so what do we have here? How many observers am I showing so far? I'm showing one object, who is the person, so that's one single observer. Okay, now, by the way, when I actually reported, did I tell you to tell me what my speed is or what my velocity is? You said, which means what? Directions are what? Are not important or important, which means everything has to have a grid with it. Okay, so let's say that this person has this grid with it. And by the way, just so you know, it has to be the same grid followed or basically possessed by all the objects. So what I mean is, if I add another object to this mix, it cannot have a grid where, for example, north points this way or north points this way. Do you see what I mean? All of them, think about it this way, all of them have the exact same crosshairs, and it doesn't matter how you walk, it's always what? Pointing the exact same way. Make sense? Has to be the exact same geographical grid. Okay, so one observer so far. All right. How many observers so far? Do we care that there's a person inside the car? No, we will always assume there is one to observe and record and report. Okay. Again, how is the grid with this one? Different or the same? Same exact grid. So we're not going to sketch it because we have it just once and we know all of them are the same. Okay. Observer number 3. Okay. Is that enough for a relative motion problem now? Because we said the minimum number is. By the way, question. Why do you think it can't work with 2? Actually, why? Okay, let's take it even worse. Why do you think it can't work with one observer? Why do you think, if the only person in the entire walking mix was Josh? Think, okay, go ahead. There's only what? One perspective. You always need a perspective, another perspective to run it by, right? Like to be like the other reporter. Why can't it work with 2? Why can't it work if only me and Josh were the one what? Doing the motion? Because who's gonna decide who's right? Is it making sense? Why could it work with 3? Because there's always gonna, what do you call a person who always makes a decision? Tiebreaker. You always need a what? A tiebreaker. And a tiebreaker is involved or not involved? Now, which means what? A tiebreaker is standing on the outside, and how many people at least are standing on the inside? 2 or more, counting 3 total. Is it making sense why we need 3? Because we need a tiebreaker. Okay. By the way, tiebreaker, I like to call it what? I like to call it absolute observer. Why do you think I'm calling it absolute observer? What's the opposite of absolute? What's today's lesson? What's the title of today's lesson? Relative. The opposite of absolute is what? Relative. What does absolute mean? When you say something is absolute, what does that mean? What's another word for absolute? Final. Or what else? Okay, you're getting there. Absolute value. Absolute means what? Non-changing. Relative could what? Could change. That's the whole idea. Okay. All right. So how many objects do I have here? 3. Let's see how they move. All right. Some of you in grade 11 will remember how this one looked like. All right. Same grid, same grid, same grid. All right, everyone. 007. Anyone in the suit is 007. Question. Did both of these people see the car move the same way? Again, forget the 3D perception thing. Did the car move the same way as observed by both of them? Both of them saw the car move in which direction? It went from here to here. So to both of them, it moved what? East. And did they both see it move the same exact speed? So should they both report the exact same velocity? Great. So if we listen to this person, the velocity of the car, go ahead, copy this one now. So the first situation is 2 observers are not moving and only one was moving. So the velocity of the car was 5 meters per second. That's your speed part. East is your direction part. Question, everyone. How would this guy report the motion of this guy? How would this observer report the motion of this person? They were not moving, so that means what? He would say that the velocity of 007 was what? 0 meters per second. But technically, since we're saying velocity, we also need a what? We need a direction. So since it's 0, we also what? Make it the same direction in the problem. Okay? How would 007 describe the motion of the car? Would he describe it differently than the other guy or the same? Okay, great. So now we know how to say all of them. Go ahead. So the velocity of the car was 5 meters per second heading east. The velocity of 007 was 0 meters per second. See, I made a mistake here. I should add the word east. So 1 second. Oops, sorry. East. And then 007 would say the velocity of the car was 5 meters per second east. Okay. Was that the first situation I did? Yes, it was. What was the second situation I did with Josh? What did I tell Josh to do? Move. Now we're going to make how many objects move? 2. All right, everyone, let's see what's going to happen. Same initial setup. Ready? Did it now take the same time for the car to reach 007 or shorter time? Because both of them were what? The distance was shrinking between them at a faster pace. Okay. Now, everyone, what do you think the guy in white is going to report the motion of the car? Is it different than before or the same? The car. It's the same. So we should also say what? What's the new motion of the car according to the absolute observer who did not move? 5 meters per second heading east. All right. How would that person, the guy in white, the absolute, Mr. Ground, who doesn't change, report the motion of 007? 5 meters per second, but heading which direction? West. Perfect. How do you think 007 now is going to report the motion of the car? Okay, before you answer that, everyone, 007, when he moved here, he kept this grid with him the whole time. So how did the car move according to this grid? East, right? It doesn't matter that he was moving his grid. It matters that the car, to him, was going this direction, east. But what's the speed now? Is it 5 or more? How much more? How much do you think? 5 plus 5 is how much? Basically, it now takes half the time to reach him. When something when something takes half the time, what does that tell you about the speed? It doubled. Remember, shorter time, higher speed. So if you half your time, you actually what? Double your speed. Yes. So the new velocity, there we go. Go ahead. 10 meters per second east. Okay. That's all well and good. But how could you actually write the mathematical equations for this? Okay. All right. So let's go now to the third slide in your handout. Okay. So everyone, pencils down. Can someone read the first subscript of the first velocity? Velocity of what? Car. And then what did I say? As seen by. Everyone, get used to 3 ways of saying the same thing. You can say as seen by. You can say, what's today's lesson? Relative to. Or you can say what? According to. I will use the 3. Most of the time, I'll either use relative or as seen by. So velocity of car as seen by 007. How many objects are mentioned here? 2. But we have how many in the problem? Which object is missing from the subscript here? Say again? The white shirt guy, right? So what does that mean? Everyone, look at the screen. Once you know which 2 objects are used and which one is missing, that missing one becomes literally, at least in this case, the middleman connection between them. So the way to actually look how it actually what finishes now. What did I start with here, everyone? What did I start with? Right here. What did I start with? So what did I start with here? Okay, what did I end with? What did I end with? What's missing from here? Where is it placed? Right where? Exactly. That's it. By the way, I just taught you the most important concept of what? Of relative motion. If you know these two, you literally know how to fill the whole thing. Okay. Can someone tell me what is the velocity of the car as seen by the watcher? The watcher obviously is the guy in white. By the way, just so you know, we're doing the second situation. Everyone, we're doing the situation where both of them are what? Both are moving together. Okay. I know, no, because technically we could be describing the first motion, but it's not that interesting. The second one is. So, Jinan, what's the velocity of the car as seen by the watcher? 5 meters per second. Which direction? Good. Can someone tell me what's the velocity of the watcher as seen by 007? Okay, before you say that, okay, everyone, pencils down. Let's use Josh as well. All right. Josh, I want you to, okay, I want you to stand right here. I want you to hold, everyone, eyes on me and Josh. I want you to hold this as you grid. Go ahead. So, where's your north? North? Yep, okay. All right. Everyone, eyes on us. You don't move. I'm going to move. Okay. Again, north, south, east, west. All right. Josh, tell me which way I'm moving with respect to you. I'm moving west. How many people agree? Raise your hand if you agree that Josh sees me or perceives me or feels me move what way? Which way? Okay. Is he moving? But does he look like he's moving with respect to me? When you drive, everyone, when you drive and two cars drive at the same speed, does it look like it's moving to you? But is it moving? Okay. How about if you're standing and it's moving? Is it moving with respect to you? Are you moving with respect to it? But in which direction? Exactly. So you see me move which way? I see him. Okay, let's not say move. I see him get further from me, but which way? Do you see what I mean? The problem with people is usually they actually study relative motion. Look, everyone, facing each other. This would be a problem, right? Because then, okay, Josh, move this way. How do you see me move? To your east. Go ahead, keep going. I also see him move what? No. Now, east. That's wrong because I'm facing him. You see how I flip my grid? No. I always have to what? Keep the grid the same. Is it making sense now? Never flip the grid because then everything is screwed up. Okay? Thank you very much, my friend. So that means, how does the watcher, sorry, the velocity of the watcher as seen by 007. How does 007 see the watcher move? Again, okay, everyone, how did the watcher see 007 move? West. So how is the 007 going to see the watcher move? East. You got it. Are my directions lined up? Can I just do the math now? What's the final answer? Say again. 10 meters which way? Isn't that what 007 saw the car move as? Yes, 007 saw the car move faster towards him at a pace of 10 meters per second. This makes sense because 007 now sees the car moving towards him at a faster pace, since the distance between them is shrinking faster than before. Yeah. Everyone, can someone tell me how many ways I could change these? How many ways can you write two things here? How many people took data management? Seriously. How many people took data management? No, seriously, this is a data management problem. You know why? How many objects do we have? How many do we choose each time? Remember Fonseca, 3, choose 2. How many? Yeah, you thought that I can't relate that to physics? I sure can. How many? Okay, A, B, C. Choose 2 of A, B, C. Go ahead. A and C. All right, choose another one. B and C. 2 choices done. Choose another one. She chose A and C. He chose A, B and C. B and A. Okay, everyone. The problem with choosing AC, AB, or BC is whether you choose AC or CA, it really shouldn't matter, right? But with relative motion, do you think it matters? Yes, it does. Because you see me differently than I see you. Do you see what I mean? So how many choices are there? How many? 6. AC and CA. AB and BA. BC and, is it making sense now? So there are 6 things I could ask you for. But do you now know how to finish the whole thing? Yes, you can, because you can just put the end and the beginning, and then sandwich in the middleman. Awesome. So, uh, Pat, need a bell. Oh, yeah. Okay, let's do another one. Let's see which random one I chose now. All right, I need someone to help me with that. Who would like to finish this one? Raise your hand if you'd like to finish this one. Ali, go ahead. And tell me how you thought of it. Tell me your thinking process. Go. Okay, so say in. So you're saying that the first one should be car 007. How many people agree? Keep going. What's the second one? Why did you choose 007 to start your second one? Why did you choose 007 to start your second one, second blank? Who can actually say why he correctly chose 007 to start this one? What's one way you can say the reason? Ammar? No. Oh, what do you guys have? Oh, then sorry. My bad. I think I made the same mistake in grade 11. Sorry. But how many people agree that Ali's thinking was still correct? He nailed it. Okay. So, Ammar, what do you guys have? A car theme by? Oh 07. All right. Oh, then, okay. Okay, sorry. You make it watcher. My bad. Oh, I copied the same slide twice. Okay, I get it. Silly me. All right. Okay, who can say then why does 007 have to start here? Because who is missing in the original one? No, sorry, I mean this one. 007. Whoever is missing, does it go on the edges or do they go in the middle? Exactly. That's how Ali thought. So let's do it. There we go. Car matches with car. Watcher matches with watcher. And whatever is not here must be the linking device. All right. Now I have a question for you. What's the velocity of the car as seen by 007? By the way, everyone, do you see how confusing it has to be said? Raise your hand if you understand what I mean. Do you see how I'm saying it opposite? Who's seeing who here? Who is seeing who? Or what is seeing what? In the first one. No, I mean here. Exactly. So never think of it as car sees 007. No, 007 sees car. But it is the way to be written. So tell me how 007 sees the car move in the second situation. 10 meters per second. Which direction? You're right. East. According to his grid, it was moving east to him. So everyone, whatever is below here, as Jinan perfectly said, it has to be 10 meters per second east. Okay, who would like to tell me velocity of 007 as seen by the watcher? Or how does the watcher, guy in white, see 007 move? Raise your hand. Ali? sorry, 5 meters per second east. East or west? West. There you go. All right. What do I do now with the directions? One of them needs to be what? Flipped. Which one do you always flip? The bigger one or the smaller one? Why? Because then the bigger positive wins. Think about it, everyone. If I can flip this one, no problem. But that will be what? An overall negative. Which means technically at the end, you still have to do another flip to clean up your answer. No, always flip the small one because then you still win a positive right there at the end. So what's my next step? 10 east minus 5 east. Yep. What is that? What's 10 east minus 5 east? If it's east, sorry, if it's the same direction, I'm done. I just have to do what the numbers tell me. Sorry. Is that correct? Is that how the watcher sees the car move? Yes, exactly, because it did not change between the first and the second situation. This is the essence of what? Of relative motion. But was this problem so far 2D or just 1D? Because everything was moving along what? East, west, okay? So, by the way, I'm mostly going to give you what kind of problems? 2D. By the way, I'm not going to give you ever 3D, okay? I mean, it still could be done, but it would be very hard to what? Very hard to what? Show a sketch or a diagram. And by the way, even in first year, rest assured, they don't give you 3D relative motion. They could, but they don't. Okay, we're gonna stick to 2D and sometimes 1D. Okay. So what's the mathematical formula now? So whenever you have A, B, C, because that's what you need as far as what the observers. So mathematical formula that relates how 3 different observers, A, B, and C, may perceive the motion is the following. There we go. Go ahead, write that down. By the way, did I have to choose A and C on this side? No, I could have chosen A and C, C and A, A and B, B and A, B and C, C and B. I just chose A and C. Why? Because I like it to read A, B, C here. That's all. So V of A as seen by C is V of A as seen by the invisible B, and then B connects again to C. You will never have to write it like that. This is the way to understand it as a storytelling, but you will never have to write like that. Because why? Because we're physics people, which means we're math people, and we don't want to write too much. We want to write as many symbols as possible, not words. So what's the way to actually write this in grade 12 physics and grade 12 calculus and vectors? Just take the words out and keep the capital letters. Please use uppercase letters. Okay? And by the way, everyone, I'm using generic ABC. What should you use in any problem? Generic or specific? Please use layers that actually what reflect the problem. Like for example, car, use C, P for person, and so on and so forth. Okay. There we go. Look how they're lined up. AC, which means what? This one connects in the middle. First is first, last is last. And that's how we do relative motion equation. Okay. See you with you in a second. Okay. All right. Everyone, by the way, before I go to the worksheet for today, make sure you understand this. Look, there are no words here, which means you have to understand. How does this one read? Not what? Not A, C, C. Do you see what I mean? Because you might actually think, oh, it's A, C, C. No, it's A as seen by C. So always know that this is just the condensed version of this very detailed way. Okay? All right, let's do. Sorry. Oh, sorry, this should be worksheet number 7 because we did worksheet number 6 yesterday. Okay, all right, let's do the easiest case of 2D, which is when things are what? Perpendicular. Okay, all right. And here it is. Again, same worksheet from grade 11. If it works, why change it? There you go. Oh, who's missed? Oh, okay. Let's start. Okay, Eric, go ahead. Read us the statement of the problem. Everyone, listen carefully. By the way, it doesn't get more word problems than relative motion. So let this sink in. Go ahead, Eric. Okay, just a second. You hover at the what? Which means to us, probably which object of all of these is not moving at all? Great. So we are going to think of this as our what? Relative or absolute observer? Keep going. Mm-hmm. So that means what? As far as you're concerned, this super advanced Navy carrier is just a big what? A big what floating in the sea? A rock, a big box. It has no power on its own. What does that mean? Wherever the what? The current goes, it what? It is perfect. Keep going. Eric. How could you see that? I don't know. Maybe there's like a piece of wood and it's just what? Floating away. And then you see it go north and you estimate it's going at a speed of 17 kilometers per hour. Keep going. Aha. Maybe it's about to take off or it just landed and slowing down. Keep going. Okay. Everyone, pencils down, eyes on me. Okay. I'm just going to use your table for a second. You're fine. Okay. What I want you to do, Khadija, you be the jet. You be the what? The F-15 jet. Okay? All right. Everyone, go ahead. Now, which way is the jet moving? Don't say east-west. Which way? To the what? To the right. Okay? Khadija, go ahead. Move it purely to the right. You could use your other hand. Trust me, I make that. I do these mistakes all the time. How did you see it move? To the what? How did everyone see it move? To the what? To the right. Okay? I want you to do the same thing. But when I start moving, you start moving as well. And you keep moving it right. And you still have to stay on the ship. Go. What's Khadija doing? Is she leaning forward? Does that make sense? What if someone says, what's the question, everyone? What's the only way that the jet would be purely moving right as seen by the helicopter? If the current is what? If the current is 0, because then what is not going to be moving? The what? The ship. This one still be moving this way. What if the ship is moving this way? Okay, wait a minute. Here's my question. Let's flip the situation. Everyone, what if the jet is not moving and only the ship is moving? So that means what? If there is no current, what will be the motion of this? Pure what? Pure to the what? If there is current, but there is no motion of this, which one would this be moving? Up, straight north. What if both motions were there? Then it doesn't make sense to just say pure right or pure up. It would be moving somewhere where exact. Do you see what I mean here? That's what 2D relative motion. Why? Because it's stuck to the ship, which means it's moving on the ship, but the ship itself is moving what? Up. How many people have walked on the conveyor belt on an airport? Okay, conveyor belt, I'm walking on it. Let's say I'm walking against it. If I perfectly time my speed, how could someone here see me? Not move at all, right? Why? Because for every step I move, what does it do to me? It pushes me back. What if I move faster? That's pushing me back. Then slowly I'm what? Moving what? Forward. What if I move slightly slower? That's pushing me back. Then I'm what? What if I'm moving perfectly as it's pushing me back? Then I'm just what? That's the treadmill principle, right? You are moving as much as it's pushing you back, right? So to someone outside, you are just what? How much is your speed? Do you see why the perspectives matter now? That's the whole idea. Okay, so let's do the first question. Eric, what's the first question? Part A. Listen up. Thank you. Can someone count how many total objects are in the problem? Actually, don't count. Tell me what they are. Who would like to give us one of the objects? Raise your hand. Helicopter. Someone give me second object. Come on. Jet. Third object, if you want. Great. Yes, absolutely. The carrying medium. Object 4. There's a fourth last object. The ship or the carrier. Perfect. Are there any other things? No, there aren't. Good. 4 objects. But we said we only need how many for a real relative problem motion? Only what? So my question to you is now, which 2 objects really see the same thing or have the same perspective or have the same motion? I'll remind you again what the objects are. Helicopter, jet, ship, current. Which 2 of them are the same? Which means I could do what with one of them? Ditch it. Can someone tell me which 2 of them? Ahmed? Say again. The ship and because both of them are moving straight what? Straight north at what speed? So do I need to keep both of them in the problem? I could ditch one because the other one's reporter or observer is going to report the same thing. You see how you think about this now? You never need to do 4. By the way, what if the ship and the current did not have the same thing? Then do you need to look at 4? Yes, you do, because each one of them has a distinct what? Perspective. Well, thank heavens they're not. Great. So let me get out of this and show you the solution to it. So everyone, first answer. Go ahead. So there are 4 objects. Sorry. There are 4 objects. Helicopter, carrier, jet, and water. However, since the water and carrier are moving exactly the same way, we can just use one of them. Randomly, I ditched the water and I kept the carrier. So we choose, you could have chosen the other way. We choose to look at the helicopter, and now I'm putting my subscript or my capital letters. We're going to call the helicopter capital H. We're going to call the jet capital J. We're going to call the carrier capital C. I could have said water, that would be capital W. So part B says, what are the relative velocities given in the problem? Well, everyone, how many numbers are you given in the problem? How many actual number values are you given in the heading of the problem? Just 2. So, sorry, you were talking about the object. I was just talking about how many numbers. 2. The first number, everyone, eyes on me, 17 kilometers per hour. In which direction? North. Yeah, north. Okay, everyone, pencils down. If you follow this way of thinking, everything will perfectly be clear. What velocity is the 17 kilometers per hour heading north? What object is moving at that speed? The carrier. As seen by who? Remember, everyone, we have three things here. 17 kilometers is the speed of the what? Of the carrier. Don't copy yet. Don't copy. As seen by who? Is it as seen by the jet or as seen by the helicopter? Okay, here's a question for you, everyone. Pencils down. If you're in a car, what's the speed of the car relative to you? You are in the car. How much? How about if you're outside of the car? It's whatever speed the car has. Do you see what I mean? So that means what? If you're on the ship, do you see the ship move? Because you're a part of the ship. So the only thing that sees the ship move out of these three things is the what? You got it. This is how you think. So carrier. Anyone remembers this from math? I know Shivers is using it. Yes, go. With respect to. Get used to this one. Not in my course, don't worry, but in math for sure. With respect to is another way of saying what? Is saying what? As seen by, according to, or relative to. So with respect to what? What did we say? So this is equal to what? V. What goes first? What goes second? You got it. All right, next one. What's the next number? Come on. 23 kilometers per hour as well, but heading which way? Nope. Who's moving at 23 kilometers per hour? Or sorry, what is moving at 23 kilometers per hour? The what? 23 kilometers per hour. The jet. The jet. Does that make sense? The jet, not the ship. Because the ship is already moving at what? 17. All right. Question. Who sees the jet move at what? At 23 kilometers. Oh, no. I love that you said helicopter. Everyone, eyes on me. Remember the whole thing I did with Khadija? Does the okay, Ammar, get up. Stand there. You are the helicopter pilot, right? If the carrier did not move, how do you see the jet move? Would there be a problem then? No, it's straightforward. Only you and this. That's it. The problem is it's moving this way, but it's also moving what? This way. So you are not seeing it purely what? Or purely to the what? You're seeing it somewhere where? In the middle of the two. Perfect. Okay. My question is, no, you're good. Who sees it? If it's not the helicopter, it has to be who? How could a carrier see a jet move? Okay. He said it has eyes. What did we always say about any object? There is what on it? An observer. Who could be the observer on the carrier? A naval officer standing. And what do they just see? What do they see move at 23 kilometers to the east? You see what I mean? Implant your own observer and look at it through their eyes. Yes. So jet, with respect to what? With respect to carrier or a Navy officer who is basically reflecting the carrier. So what is this? J. Yep. You got it. Done. All right. Go ahead. So 17 kilometers north, pure north, is nothing but the movement of the carrier away from you, you being the helicopter pilot, because you are the absolute observer. Nothing is relative. Sorry, nothing. Sorry, you are not moving with respect to anything else. 23 is the velocity of the jet, not to you as the helicopter pilot, but to someone who is standing and observing the jet on the carrier. Okay, look at the last question, which is obviously the whole point of doing this problem. What would the, or how would you, sorry, how would you, the helicopter pilot, H, see the motion of the jet? So am I asking you for this, everyone? Am I asking for this or this? Remember, they're not the same. Which one Because, by the way, if you chose the wrong one, could that make your final answer wrong as well? Yeah, because remember, placing them is going to screw up everything else. Who can tell me which one, according to the question, am I asking for? HG or JH? Who says HG? Who says JH? Ayat, why did you vote for JH? Explain. Listen, everyone. Yeah. Okay, how about this? No, you're right. How about this? Can you expand that notation and see if it aligns with what you just said? Go ahead. What does JH mean, Ayat? Is that what the question is asking? Yes. Jet with respect to helicopter means how does the helicopter see the what? Can someone tell me how to finish this equation now? Because that's the whole idea. If you know how to start, you definitely know how to end. Who would like to finish this? Blank, 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 blank. By the way, biggest mistake, people only put how many blanks? Can you have a relative motion where you only mention one object only? No, you need another what? Referee. All right? So let's start with, go ahead. So everyone, whenever you have 2D, do you just add up or do you have to go through the labor of triangles? You have to go through the labor of what? Of triangles and trig and all of that. All right. Done. Where do you start the second vector? When the first one ends. Is it making sense now? That's the only way this is going to happen because the plane is going to veer east and north. That's how we do relative motion for triangles that are right triangles. So the magnitude of the speed of the what? Of the jet as seen by the helicopter guy is 28.6. However, the deflection angle is what? 36.5. That's how the helicopter pilot would see the what? Would see the jet move. Combining the movement of the what? Combining the movement of the current and the jet together. Okay, I'm gonna stop right here. I know we still have another demo problem and another problem that is not a right triangle. We're just gonna finish them tomorrow. Don't worry about that. Because tomorrow I just want to spend the whole day doing university problems, like we did on Friday, purely on what relative motion, because it's a big part of first year kinematics physics, huge part. So before we're done for the day, I mean we're done. I just want to show you. You have a couple of links in your notes. I want you to play a little bit with this animation when you go home at any point. Okay, what do we have here? This is the velocity of what? Velocity of the what? According to who? What does Earth mean? The ground observer, right? Or the absolute one. Okay. What if I make this 0? What does that mean? Is there any current in the river? So what do you expect is going to happen to this boat once it moves? Where is it going to reach on the other bank? Right, left, or straight ahead? Why? Because it's neither pushed back or, sorry, like, downstream or upstream. Okay? Run. That makes perfect sense. Okay. What if I do this now? Just a little bit. What's going to happen? Is it going to perfectly go head on or deflect a little bit? It's going to deflect, but not. Okay, look where it's going to hit. Everyone? Slightly off. What if I do this, everyone? What if I do this and this? Who's winning now? The river or the boat? Yeah. 5 times as fast push, 1 meters per second. What do you think is going to end? Way downstream. By the way, downstream means with the stream, upstream means against it. Oh, show velocity vectors. There we go. And if I, you see what's happening? What kind of a triangle do we have? All right, angle triangle, just like the jet problem we just did. Oh, you can even, oh, okay, question. what if you, everyone, what if you move this way? Sorry, everyone. What if the current is moving this way, but you still want to end here? How do you drive the boat? Exactly. You want to go against, right? Because then you're going to go this way, but then you're going to be balanced this way. So that's what. So for example, if I minus 30, all right, let's see. Okay. Oh, it's 0. Okay, that makes sense. If you basically do trigonometry, you see what I mean? That's the whole idea. That's why relative motion is important with what? Navigating boats and planes. You either fly with the wind or against the wind. With the wind, if you actually want it to speed you faster. Against the wind, if you want to go into it, so it could deflect you more. So a helicopter, yes, a helicopter flies with an air speed. Okay, everyone, every single time you hear the term airspeed, airspeed, it means the velocity of the plane with respect to what? With respect to what? With respect to air. By the way, they either use air or wind. They mean the same thing. Okay? So this is the velocity of the plane or of the helicopter according to or relative to what? Relative to air or wind. Okay. Heading which way? Heading which way? Heading south, straight south. Okay. The wind is blowing at 85 kilometers to the what? To the east, relative to the ground. So can someone tell me what are the objects mentioned in this problem? Remember, the minimum number you need for a relative motion problem is how many? 3 objects. What 3 objects can you identify here? Ahmed, give us just one. The ground. Okay, someone who is the absolute observer, just looking up. Object number 2 or observer number 2, Eric, the helicopter. Observer number 3 or object number 3. What's left? Is it flying in vacuum? No, it's what? The wind or the air. Okay? All right, perfect. So calculate the speed and direction of the helicopter. How come they did not tell you relative to what? Okay, let's think about this. We have the velocity of the helicopter relative to what? Relative to air. So the only other relative speed to the helicopter should be to the what? Is there such a thing as a helicopter relative to helicopter itself? No. So if the helicopter has already been related to air, now it could be related to the what? To the ground. Exactly. Perfect. Okay. So under the statement, everyone, let's actually write the things we know. So it's the velocity of what? What object? Helicopter. What subscript should you use for helicopter? Capital H. Yes. Capital H. Relative to. Relative to. Now, by the way, you see how the problem calls it both air and wind. We have to choose one name. Okay. Let's call it what? Let's call it wind. Okay. So helicopter relative to the wind. Relative to the wind. Okay. What's the other velocity? 85 kilometers per hour. In which direction? Which direction? East. This is the velocity of what relative to what? This is the velocity of the what? Wind, according to someone on the. Perfect. So WG. WG. What's the question asking for? The speed and direction, aka velocity or relative velocity of the what? But the helicopter has already been related to the what? So now we have to relate the helicopter to the. Perfect. Okay. All right. So V W. So not W. H G equals what? Question mark. This is the one we're trying to what? This is the one we're trying to find. Does this look like somewhat the jet F-15 problem? What directions do we have, by the way? What are the only 2 directions mentioned in the problem? South and What's so special about the south and east? They're what to each other? Perpendicular. So this is still a what? A right triangle problem. Okay. Now let's go to the what? Now let's go to the next slide. Let's go to the next slide and actually what? Start with the solution. All right. So, okay. Can someone finish this equation for me now? V helicopter relative to ground equals V what plus V what? Remember, finishing the equation is the starting point to at least knowing how to sketch the diagram. Who would like to give me the first relative velocity on the right side of the equation? The first relative velocity. Yep, Ahmed. Yep, you have to you start with h here, which means you have to start also with h here, and obviously the middle person has to be in the middle. Okay, who would like to give me the next one? Yep, Eric. When exactly these two have to connect. This one has to connect with itself here, and then whatever's last is also last. Okay, that's good. All right. By the way, if you write the equation properly, you do not have to have another line writing the equation in what in the actual numbers. You can start right now with the what? With the diagram. Which vector should I sketch first? Which vector is mentioned first on the right-hand side? The helicopter with the wind. Which way is it going? The helicopter with the wind. It's going south. And how long is it? Okay, the other vector is going which way? East. And it's how long? So roughly, what's the factor between 175 and 85? Roughly. By the way, it doesn't have to be perfectly to scale. But how big is 175 roughly compared to 85? Yeah, try it. 85 times 2 is exactly 170. Perfect. So that means what? Whatever vector you sketch for the south has to be how many times longer than the east? Twice as much or double as much. Okay. By the way, are we going to sketch both of them starting from the same point or one picking up after the other? Yes. Otherwise, you would get the exact hypotenuse, but wrong direction. Okay. So obviously, the first one we're going to start with was, which one was the first one in the equation, in the relative velocity equation? HW. So I have to start going south, and then I have to turn east. So I have to go to the right. So maybe a good spot for the sketch would be, let's sketch here. Okay, everyone, let's sketch here. I'll sketch roughly as usual. Go straight down, that much, and then go this way. I think this is double. Oh, sorry, I mean half. Perfect. So this one will be V. Please make sure you put the arrow on top because it's a velocity. V H W. And this one would be V W G. Okay, this one will be 175, 175, and this one will be 85. Good. So that means, boom, that's it. What do you call this angle? What's the symbol for angles in math? Theta. By the way, you can see that I never label ABC for what? For right triangles, right? We usually label ABC for what kind of triangles? Non-right triangles like oblique. Why? Because then you need those for the sine law and the what? And the cosine law. You never need ABC for the what? For SOHCAHTOA. You just need hypotenuse, opposite, and adjacent. Uh, so yeah. Okay, let's start. What do we usually start with? Pythagorean or SOHCAHTOA? Usually. Again, you can start with SOHCAHTOA. It doesn't matter. You're gonna have to do, and both of them are independent of each other. But I like to start with what? With Pythagorean first. I'm more interested in getting the magnitude first. All right, let's do this. So c squared equals a squared plus b squared. Or everyone, or if you want to jump ahead to the what? To the square rooting, please feel free. I am the last one to take a mark off for this. I'm okay with different steps as long as you know how they started. Okay, so that would be, take this one out. All right, equals square root of 185 squared. sorry, 175 squared plus 85 squared. All right, let's jump to the final answer. I've got my trusty calculator right here. Okay, 175 squared plus 85 squared equals square rooted in one shot. There we go. What's the sig fig situation for this problem? 175 has 2, 85 has 2. So what should we do? How many sig figs should we keep? 2. What would that be to 2 sig figs? 190. So, okay. So this, if you cut it right here, if you cut right here, what does it become? 190 or 12? Is it closer to 190 or 200? So 190. Is 190 already, what do you call it? 2 sig fig? Yes, it is. Great. So 190 kilometers per hour. Technically, that's still speed. All right. That's my magnitude. Now I need my what? My angle. Theta equals, is it sine, cosine, or tan all the time for right triangles? Yep, tan. Why? Because you already know the opposite exactly, and you know the adjacent exactly. The 190 kilometer for the hypotenuse is a rounded value. Don't use that. So tan inverse of, yep, opposite over adjacent. And in this case, the opposite happens to be the 85, and the adjacent happens to be the other one. All right, equals, if you have everyone, if you have a single display, not a double display, if you have a double display, you can actually write this entire expression in it in one shot. If you have a single display, this is my suggestion to you, because mine is also a single display. I would rather do this first. So 85 divided by 175, which is slightly less than half, as you can see, 0.48. And then keeping the whole number if you like, go to trig. What do I have to press first? Shift or second, because I'm going backwards. You have to see the -1 on top of these trigs. And which one am I going to use? 10, because it is what it is here. 10. Perfect. So what is this to 2 sig figs? 26. It is rounded definitely to 26 degrees. So 26 degrees. Done. So the final statement should be this. V helicopter ground equals 190 kilometers per hour. What should be the first direction according to that triangle? Remember, you're starting from here and you're ending here. Which direction first? Apparently, you had to go south first and then veer what? East. Perfect. So south, east, 26. Done. Now let's do a problem where things are not perpendicular anymore. All right. Okay. The last problem in your handout, in your slideshow. Okay. An airplane flies due south. Sorry, due north over Sudbury with a velocity relative to the air of 235 kilometers and with a wind velocity of 65 kilometers per hour. What does northeast mean? What's the only angle that does not have to be given inside of the square bracket? Noura, can you guess? 45, because obviously that's the only way where northeast, north 45 east is the same as what? East 45 north. So whenever it says just purely northeast, it means the angle is perfectly between the north and the east, and that could only happen if it's 45. Good. Calculate the speed and direction of the what? Of the airplane. Now, again, which velocity do you want of the plane? The velocity of the plane relative to the what? Again, relative to the ground. Why? Because this flies due north over Sudbury with a velocity relative to the air and a wind velocity relative to the ground. By the way, they never mention usually what the wind velocity is relative to. It's always relative to the what? To the what? To the ground. Someone is looking up and they see a piece of paper fly. This is how they know exactly what speed and what velocity the wind is going through, is when it's going at. Okay? All right. So everyone, this is north. Okay? But the problem is the wind is blowing which way? Which way is the wind blowing? North, northeast. So that means if the plane is trying to move this way, there is northeast wind pushing it somewhere, deflecting it that way. So, yes, this is the wind, which means the plane is going to end up moving which way? So that's basically what the 3D version of it. Can you see how we can make this into a 2D? Yeah, just imagine yourself looking from the what? From the top side up. All right. So let's start with what? So go ahead. So with rulers, create the what? Create the 3 vectors on that grid. So the first one is what? V plane according to wind. V plane according to wind. I'm going to add the arrows on top because I couldn't do them in Microsoft and PowerPoint. Oops, sorry. V, V. All right. And how long is that vector? That vector is 235. Yes, 235. I don't care, by the way, if you put the magnitude of the vector at its end or somewhere in the center of it. Doesn't really matter. Like here, for example, you can put 235 here if you want it. 100% either way. Okay, what's my second vector? My second vector is from the end of that one, not at the beginning. No, from the end, 45 degrees northeast, which means that way. So you have to imagine basically a very small XY axis here, and you go 45 northeast or 45 east north. Who cares? It's the same thing. And the scale of this one, now what's the scale of 65 and 235 roughly? Well, 235 is very close to 240, right? 65 is very close to what? 60, 6 and 24. That's 1 to 4. Perfect. So whatever you sketch here should roughly be 1/4 of this. Obviously here it's more like 1/3, but again, who cares? This is just a scale. Although yesterday, as so many people talked to me yesterday, scale mattered in yesterday's what? Quiz problem, right? Because it really made sure you ended in the right quadrant. So that would be my 65, 45 degrees that way, and that would be 65 kilometers per hour, which means the last one has to be going from the beginning all the way to the end that way. Sorry, that's WG. Then the last one, of course, has to be that way. CP. Sorry. 45. Okay. We have to label, I guess. Which side length are we trying to find according to that labeling? C. What is the cosine law starting with c squared? Anyone? Remember, it's like you're starting with the Pythagorean theorem. Ammar, go ahead. You have to end with cos because it's a what? It's a cosine law. And there we go. All right. The rest is just what? The mechanical plugging in of all of the values we know. All right. So my A is the 65. My B is the 235. Okay, I've done the whole thing. Feel free to write this. Actually, in your notes, please just leave some space and write this one space below to actually show yourself the actual plugin in. By the way, if you have a single space, my suggestion, everyone, for this calculation is not to actually start from the left side, to start from the what? From the right side, okay? Let me show you how it actually plug this in. First of all, I have to hit the cosine. So obviously I have to put 135. It's 135, right? Yeah, 45 plus 90. And then I go to trig. Do I put second? No, because I already know the angle. You only put second when you want to find the angle. So cosine. Does it make sense to be minus? What rule did we draw here last week? The what rule? The circle. What did you call it? The cast rule. And anything what? Anything on the left side of the quadrants definitely has a what? A negative cosine. So that makes sense. Which is interesting because that means this negative times this negative will be what? And that's how you're going to get what? A length longer than both of them like in the triangle. That's the only way. Otherwise, you're going to get a length less, which doesn't make sense. So times B and C, B and A. So what's B? Who cares? It's 65 and 235. And 2 with a what? With a what? With a negative. Okay, perfect. Plus what? Plus this guy, plus this guy. So plus 65 squared equals plus 235 squared equals, and then what do I do with this? Square root it. I find that to be the safest way if you want to do it what in one shot on your calculator without writing middle step by hand. Basically, start from the calculation that has the most elaborate multiplication in it, which is the 2ab cosine c. Kinda, yes. Oh, sorry, yes, I guess I didn't change this one. My bad. So is it 2 sig figs? It is 2 sig figs. So what would this be to 2 sig figs? Is it 284 or 280? Sorry, is it 280 or 290? Obviously 280, so thank you, you're right. So everyone, this will be 280. All right. By the way, usually when I go back to what? When I go back to calculations, I do not use the what? The final answer. I use the what? I use an intermediate step. You see why? Because just to keep more what? More accuracy in, not precision, more accuracy in my what? In my eventual answer for the second step, which is the angle. Now, what would this be to 2 sig figs? 929. Is that closer to 920 or 930? 930. All right. So this will be 9. Oh, sorry, 9.3. I mean 9.3. Great. So this will be 280, and this will be 9.3.